Let's take a look at some of these functions questions. Question 4 reads the graph of f of x is equal to 4 divided by x minus 3 plus 4 is drawn below. M is the midpoint where the asymptotes of f intersect. C and D are the x and y intercepts respectively. A is the point on f that is closest to M. Okay, so they start off with some easy questions. 4.1, write down the coordinates of M. So the coordinates of M are simply going to be from the equation. So 4.1, the equation of the asymptotes, you're going to have x is equal to 3 and y is equal to 4. So M is going to be 3 and 4. So then question 4.2, calculate the coordinate of D. So D is the y-intercept of the function. And so if I want to solve for the y-intercept, I simply make x 0. So y is equal to 4 divided by 0 minus 3 plus 4. So y is equal to minus 4 over 3 plus 4. And that's going to be y equals, I think, 2,67. Yeah, 2,67 sounds right. But remember, they want it in coordinate form. So it will be 0 and 2,67. Question 4.3. If y equals x plus t is the equation of a line of symmetry, calculate the value for t. Now to get the equation of the lines of symmetry, I'm just going to read it off like so. So I'm going to read it as y is equal to x minus 3 plus 4. Y is then equal to x plus 1. And so t is equal to 1. Question 4.4. Determine the value of x for which f of x is less than or equal to 0. So I need to evaluate this function, and I need to kind of I want to solve it graphically. So I'm just going to quickly highlight where I'm seeing the graph being negative. And so the graph is being negative here. So just below this point. So my answer is definitely then going to be that x is going to be, or x needs to be between these two values, because that's where the function is going to be negative. So now I need to solve for the x-intercept. And to solve for the x-intercept, make y 0. So 0 is equal to 4 over x minus 3 plus 4. I'm going to take the 4 across. So minus 4 is equal to 4 over x minus 3. I'm then going to cross multiply here. So minus 4 into x minus 3 is equal to 4. So minus 4x plus 12 is equal to 4. I'll then transpose the 12. So minus 4x is equal to 4 minus 12, which is negative 8. X is then equal to 2. So this point right here is going to be 2. So the answer then is that x can be greater than or equal to 2, but less than 3. It can't equal to 3 because that's an asymptote. Now let's move on to question 4.5. Calculate the coordinate of A. Now, they tell us that it is the point that is closest to M. And so when I'm thinking of a solution here, I'm thinking that if I had to fold this point on a line of symmetry, it's not going to move because it's the closest point. So then immediately what I think of doing is I think of equating the function to the line of symmetry. And we can do that by simply saying 4 over x minus 3 plus 4 is equal to, and so remember this line of symmetry is the one that has a positive gradient, so x plus 1. And we worked it out in the previous question. So 4 over x minus 3 plus 3 is equal to x. And now I want to get rid of the denominator x minus 3, so I'll multiply all the terms by x minus 3. So 4 plus 3 into x minus 3 is equal to x into x minus 3. Let's simplify. So 4 plus 3x minus 9 is equal to x squared minus 3x. And so I expect to get two values because there's 2 points of intersection. And so I am seeing that I'm probably going to get a quadratic. So let's just write it in the quadratic form. So 0 is equal to x squared minus 3x. And then I'll take that 3x across, becomes minus 3x. And 4 minus 9 is minus 5. And if I take that over, it becomes plus 5. So 0 is equal to x squared minus 6x plus 5. Now we factorize. So 0 is equal to x minus 5 and then x minus 1. X is therefore equal to 5 or 1. Now, since point A lies on the right of my asymptote, remember the asymptote is at 3, so I'm going to choose 5. Yeah, I'm going to choose 5. And so then the coordinate of A is going to be, remember I can solve that for the y value, it's going to be 5 plus 1, which is 6. So A is then going to be 5 and 6. Then the last one, 4.6. A single transformation is applied to f to obtain a new graph defined as h of x is equal to minus 4 over x plus 3 plus 4. A prime is the image of A under this transformation. Calculate the length of A prime. So the first thing I need to do is I want to figure out what this transformation was. I know it's a single transformation, and so I'm suspecting that it's a reflection. Now, I don't think it's a reflection on the x-axis because I would have gotten a negative value, a negative 4. So I'm going to see if it could be a reflection over the y-axis. And when I do a reflection over the y-axis, I just need to remember that a reflection over the y-axis means that I keep the y value, but I change the x value. So y is equal to 4 over, the x becomes negative x. So minus x minus 3 plus 4. But it doesn't look like the one that we've been given. So I just want to see if I can just rewrite it a bit. So y is equal to 4 over minus into x plus 3. And now I think it's a bit more clear what we are doing. So then this minus can go to the top, it doesn't matter. So y is equal to minus 4 over x plus 3 plus 4. And so that so that we can see that it works, it means that it is a reflection on the y-axis. And now that we can focus, now that we know what the reflection is, we can focus on point A. So if A is 5 and 6, then A prime is going to be, so reflection on the y-axis, keep the y value, change the x value. So then we just need to evaluate what is the distance between 5 and minus 5, and the distance is 10. So A prime is 10. Now I want to take a look at question 5, which reads the graph of f of x is equal to a into x plus p all squared plus q, drawn below. C minus 1 and 4 is the turning point of f. B minus 3 minus 4 is a point on f. 5.1 show that f of x is equal to minus 2x squared minus 4x plus 2. So immediately I think of the form of the quadratic formula that uses the turning points. So I'm going to just quickly write that out. So y is equal to a into x minus p all squared plus q. Now I know the turning points. The turning points are minus 1 and 4. So I'm going to substitute those points in. So y is equal to a into x minus minus 1 is x plus 1 all squared plus 4. Now I need a point to substitute. I'm going to substitute point B. Point B is minus 3 and minus 4. So minus 4 is equal to a into minus 3 plus 1 all squared plus 4. I'll then transpose the 4 over. So it's minus 4, which is minus 8, is equal to a into minus 3 plus 1 is minus 2, so minus 2 squared. Minus 8 is equal to a multiplied by minus 2 squared is 4. Now I divide both sides by 4. So minus 8 divided by 4 is minus 2. So minus 2 is equal to a. And that works. Now, basically to figure out the rest of the formula, just substitute that a value back into our equation right here. So y is equal to minus 2 into x plus 1 all squared plus 4. So minus 2 into x squared plus 2x plus 1 plus 4. That's minus 2x squared minus 4x minus 2 plus 4. And that's minus 2x squared minus 4x plus 2. And there, we've done it. Question 5.2. Determine the values of k for which h of x is equal to f of x plus k will have no real roots. There's actually a few ways to do it, though I want to, again, try to solve this one graphically. So when will the function have no real roots? It will have no real roots when it doesn't cut the x-axis. So how do we translate this graph such that it has no x-intercepts? So all we need to do is we need to focus on our turning point because that represents our maximum value. And what I want to do is I want to shift that graph down. So k needs to be a negative value. And I need to shift it down by more than 4 units. So that's it, because if I shift it down by more than 4 units, or 4 units and below, the function will look something like that, and it doesn't cut the x-axis anywhere, and so it will have no real roots. So all I need to do is I just need to state that k needs to be less than minus 4. So minus 4 will work, actually less than or equal to minus 4. No, less than 4, less than minus 4. Yeah, that's correct. Okay, now of course you can do it the other way, where you do, you can say that the delta must be less than 0, but that will also work. Question 5.3, the graph of y equals g prime x, where g prime is the derivative of g, is obtained when f is reflected over the line y equals 4. Draw a sketch graph of g if g0 is less than 0. Clearly indicate any stationary points. So here what I want to try and do is I want to figure out what's this new function going to be and what is it going to look like. So if we're reflecting this function f on the line y equals 0 or y equals 4, here's the line right here. So since this point lies on that line, it's not going to move anywhere. And so you can, I think of it more of like it's as a fixed point that's being reflected. And so I see the new function probably going to look something like this. Now what I want to do is I want to figure out what the function is going to be and also what's the y-intercept going to be. So if this value is 2 and the distance from here to here is 2, that means the distance from here to the y-intercept should also be 2. So 2, 4, and then 6. So this value will be 6. Now, it's basically reflecting it. So these values here should become positive because you are changing you're keeping the y value, you're just changing the x value. So the function is going to be, g prime is going to be 2x squared plus 4x plus 6. Now, they want us to sketch the graph of g. So g is the original function, and g prime is the derivative of it. Now, to do this, there's actually a few ways you can think of it. Well, firstly, I'm seeing here that my a value is positive, right? So that's obviously something to note. So a is greater than 0. And then secondly, I want to figure out if there's going to be any stationary points or turning points. So to figure that out, we need to see if there's any real roots for this function. And so if we try and figure this out, we're going to have 0 is equal to 2x squared plus 4x plus 6. We can then simplify 0 is equal to x squared plus 2x plus 3. Now there's no way that we can factorize this without the quadratic formula. There's no values that you can choose. So there's going to be no real roots, right? And so if there's no real roots, then there's no turning point, or no stationary points rather. So if there's no stationary points, and the a value is greater than 0, that means it's just an increasing curve since this a value is positive. So I'm expecting the function to look something like this. And then they tell us that g0 is less than 0. And that basically means that the y-intercept is negative. So all we need to do is just copy the same shape, but it needs to cut the y-axis in a negative point. And so that's basically the shape. Let's take a look at question number 6. The graphs of f of x equals p to the power of x plus q and g of x equals mx plus c are drawn below. A, 3 and 4 is the point of intersection of f and g. B, 0 and negative 3 is the x-intercept of f. E is the x-intercept of g. So the question says, calculate the value of p and q. So I'll start by writing up my formula. Y is equal to p to the power of x plus q. Now I want to substitute the y-intercept in. So remember, the y-intercept is 0 and negative 3. So negative 3 is equal to p to the power of 0 plus q. Anything to the power of 0 is 1, so 1 plus q is equal to negative 3. You take the 1 over, negative 4 is equal to q. So now my equation is basically y is equal to p to the power of x minus 4. Now we can substitute a point in and then solve for p. We have another point, 3 and 4. So 4 is equal to p to the power of 3 minus 4. 8 is equal to p to the power of 3. So something to the power of 3 is 8. I think this is quite straightforward. P is then equal to 2. So we have our values for p and q. Question 6.2 reads, write down the range of f. So the graph of f. Okay, so here we go. So range refers to y values. So y is an element of real numbers, but y must be greater than the asymptote, and the asymptote is minus 4. Now question 6.3 says the graph of g to the power minus 1, the inverse of g, also passes through b. Determine the equation of g in the form y equals. So I'm going to write down the equation y equals mx plus c. That's going to represent, of course, the function for g. And then I'm going to write the inverse. So to get the inverse, we switch the y and the x. So x is equal to my plus c. Now we just need to substitute a point that lies on both of them. So I know that on G, there is a point A. So I'm going to substitute the coordinates for A. 4 is equal to 3m plus c. And now for the inverse, they tell me that it lies or it passes through B. So I can substitute the coordinate for B in. So 0 is equal to minus 3m plus c. And so I can just write here 3m is equal to c and substitute this into my other equation. So 4 is equal to 3m plus 3m. 4 is equal to 6m. M is equal to 4 over 6, which is 2 over 3. And so if I want to calculate the c value will be 3 times 2 over 3, and that's going to cancel, and so c is going to equal to 2. So my equation is going to be y equals 2 over 3x plus 2. Okay, and let's move on to the next one, which is write down the equation of g to the power minus 1 in the form y equals. So if my original equation is y is equal to 2 over 3x plus 2, I need to switch the x and y. So x is equal to 2 over 3y plus 2. Take the 2 over, so x minus 2 is equal to 2 over 3y. Now divide the whole thing by 2 over 3. So x minus 2 divided by 2 over 3 is equal to y. Of course, now we can go a bit further, and let's do that. So what we can do now is you can say y is equal to x over 2 over 3 minus 2 over 2 over 3. Now remember, x divided by 2 over 3 is the same as x times 3 over 2. So that's going to be 3x over 2. So this is equal to y is equal to 3x over 2. And same thing will go for the other one. 2 divided by 2 over 3 is the same as 2 times 3 over 2. So that's 6 over 2, which is 3. So this is going to be minus 3. Okay, thanks so much for watching. Be sure to like, share, and subscribe for more videos like this. I'll see you in the next video. Bye.